scenario where you walk into a department store and you got a bonus at work, so you have a little extra cash in your pocket. And so you start picking up all sorts of things that you want to try on. You take them into the dressing room, and the things that you really like, you go ahead and put them into one pile. The things that you don't like, they go in another pile. And the things that you're kind of on the fence about, you put them in this third pile. Now, imagine that this mirror here is actually a smart mirror. And it's been keeping track of the decisions that you've been making. So much so that now it's able to recommend to you other products in the store that it's pretty sure that you would love. Not only that, there's buttons there, so you can click the button of any of the products, and a sales clerk will bring you that item in your size. Pretty cool. What's even cooler about this is that the technology for such a system exists today. So my question to you is, how would you test this? Think about it. Would you even know where to begin? Now, there are a lot of teams that are using machine learning to implement certain features. And oftentimes, I hear this general consensus that, oh, we don't need to test that feature. That's the machine learning feature. And everyone just kind of nods and goes, oh, okay. As if it's this black box of magic that just works, right? I don't know about you all, but I watch the news. And there have certainly been some mishaps where machine learning is involved. So it terrifies me when I hear this mindset, especially when there are more and more companies that are utilizing machine learning in our everyday applications. Such as Netflix. How many people use Netflix? All of us do, right? Almost on a daily basis. When you log into Netflix, the very first screen that you see is your page, right? And this is your recommendations page, and it's driven by machine learning. Now, 80% of what we watch comes from what's recommended to us. So this is pretty important to Netflix's business model that they get this right. But what is right? How do we test something like this? I know myself better than anyone else, and I can't say for sure if my Netflix recommendations page is correct or not. How do I know that things there are what should be there, or there aren't better things that can be shown? And then there's Twitter. I used to work there up until last year, and we had quite a few features that utilized machine learning, one of which was to detect spam on the platform. So, say you have this tweet that says, message us if you're looking to buy some followers, $2 per 1K. This is clearly spam, but how do we know that this is spam? Is it the words that are being used here? Because if we look at this other tweet, it says, hey, wannabe celeb, you have a total of 2K fans. Why don't you go buy some followers? Same verbiage, different context, right? And this is not spam. Rude, but not spam. So how do you test something like this? And then there's Watson. This is IBM's AI machine. And Watson can do some amazing types of things, such as it can prescribe a customized treatment plan for cancer patients based on that patient's DNA, as well as the evaluation of millions of records of medical literature and clinical trials. It's pretty important to test something like this, I think, right? It's pretty important that we get this correct, but how do we know? How do we know that this is right before we actually give it to a patient? So I could stand before you today. I could give you a bunch of theory on machine learning, but I think I'm most effective when I share my personal stories. And fortunately, I have had the opportunity of working on applications that utilize machine learning. So I would love to share a story with you all, if that's okay. Cool? All right, let's do it. So once upon a time, I worked at a company where we used this ad recommendation system. We built this. This is what we provided. And the way it works is third-party e-commerce companies could give us all of their ad inventory. We would keep record of that. And then they could make an API call to us anytime they were interacting with a live customer. And in that API call, they would pass in some information about the customer. So this is a woman who's 21 years old. Based on that data, we would respond to that call with what's the best ad that you can show this person. Now, our key ingredient here was machine learning. So as a customer or one of our customers would utilize this more and more, we would get better at the recommendations that we were telling them to show, thus making them better at their conversion rates. So I had to answer this question: how do you test this? At this point in time, I didn't even know what machine learning was. Hadn't heard of it. So I had to do some research, and I found a lot about the theory of it. I found things about libraries. I found algorithms. I didn't find much on how do you test this stuff, right? So I had to come up with my own plan, right or wrong. That's what I'm going to share with you today. So the very first thing I needed to do was to learn how the system learns. So there was one guy on the team. He was the subject matter expert in machine learning. Let's call him resident expert. So resident expert, he was brilliant, right? But he wasn't really great at helping you to understand things. So I went to him asking about, okay, how does our system learn? Please help me. And he would talk about the theory of machine learning. He would go over a lot of jargon, and quite frankly, most of it was over my head. So I took what he said, I took the research that I'd done, and then I also decided to go poking around the code a bit. Now, I have a master's degree in computer science, but I'm not afraid to admit this stuff was pretty complex. It was over my head. But I got as much as I could, and here's what I found out about the system. In general, machine learning, there is no exact predictable outcome. Now, me, being an automation engineer, I grew up on the notion that in order to test something, you had to know what was the result. Right? You add something to your cart that costs $5, you increase the quantity to 3, then your subtotal is what? 15, exact, testable, automatable, right? In machine learning, that was not the case. So that was really interesting to me. As far as our product and how it learned, the product, if it hadn't learned anything yet, then it would just recommend random ads to people. And our customers, when we would give them that response, they could then make another API call to us to let us know what happened. Did the customer accept this, or did they reject it? Based on that, our system would create these models. And these models represented what they learned, what the system learned. And then it would consult these models when it needed to make future decisions. So that's where the learning occurred. Another thing I figured out is that it had to have enough data to be able to recognize some patterns here. So 1 or 2 things wasn't enough. Ideally, a couple of thousand things would help it learn better. So once I figured out how the system learned, the next thing I needed to do was to train the system. So this is where you give it a scenario. What is it that you want it to learn? So I went with a very simple, basic, yet stereotypical scenario. I wanted the system to learn that women like dresses and men like pants. And so that was my scenario that I was going to go with. The way I did this is I created a script. I did 2,000 API calls in this script to represent 2,000 unique customers. I generated their unique ID randomly in the code, so these were all new people. And then I would also randomly generate their gender of male or female. And so because I was doing that randomly, it would be about 48 to 50% of either gender. I went with 5 ads, not just the dress and the pants, but 3 other ones as well. And because there were 5 of them, then each one of them would be shown 20% of the time before it learns anything. Next, I wanted to accept. So this is the second API call where I say, yes, I am accepting this dress ad, meaning I went on to buy something or rejecting it, right? So at first I was gonna set this up to be like 100% of the time that a woman saw a dress, she would go ahead and accept it, but I thought that's not really realistic. And I wanted to make sure that the system wasn't only working when 100% of something was happening. So I scaled this down to something more realistically. 65% of the time that men saw the pants, they would buy. 65% of the time women saw the dress, they would buy. And then 2% of the time, no matter who the customer is, no matter what the ad is, they would buy, because I wanted to generate models for all 5 of the ads. With me? All right, that's the extent of my math. I lied, more numbers. All right, so then I needed to create this data structure in my script to hold the data. The first column represents each of the ads, and then the second column is the number of women who saw each of the ads after this thing was run. So we see roughly about 200 women saw each ad, which is perfect. That's the 20% of the 1,000 women. And then as far as accepting or purchasing the dress, I had it where 133 of the 202 women who saw the dress actually went on to buy it, and then 3 or less of the other ads. The men, 196 who saw the pants, 128 of those actually went on to buy it, and then 3 or less for the other ones. So I had trained the system. Now it was time to actually test it. This is where I kind of got stuck. So I don't know, again, what it is I'm supposed to expect. I'm writing a script here. I'm automating this. I have to write an assertion here, right? What do I put? And I didn't know. So I went and asked Resident Expert. I understand that there's a range of validity here. What's that range? And Resident Expert didn't know either, right? And so I'm like, okay, there's nothing that I can hard code here. Let me just use the POX method. The POX method is plain old common sense. And what the POX method told me is that if before learning, 20% of the women saw the dress, same for the men in the pants, then after learning, it should be greater than 20% and less than 20% for all the other 4 ads. So that's all I had to go with. So I started there, and when I ran this again, I ran the script again. I remember the IDs are uniquely generated, so these were 2,000 new customers when I ran again. So I looked at my results. The number of women who saw the ad before learning was 202. The women who saw after was 890. Yes, learning is working. And then I went over to the blokes. So there was 196 men who saw the trousers before learning, but only 59 after learning. Then I looked at their numbers for the dresses. 204 men saw the dresses before learning, and 874 saw it after? That's weird. So I began to wonder, what did I do wrong, right? I barely know about this machine learning stuff. I don't know why they put me on this project, is what I told myself. So I began going through my code, and I'm looking at the lines. Everything looks okay, but hey, I deleted all the models. I said, let me rerun this. I reran the entire thing, and I got a different result this time. This time, the men did see the pants more after learning, but so did the women. So now I'm really confused, right? I delete the models. I said, oh, I do remember that it needs enough information to be able to learn a pattern. So maybe 2,000 wasn't enough. Maybe I can crank this thing up to 10,000 customers, and then it'll see the pattern. So I tried that. Same thing. It was flip-flopping between the dress and the pants. So I went ahead and printed out that data structure from a couple of different runs so that I can try to figure out what in the heck is going on here. And what I saw was that, remember, I was automatically generating the gender in my code. So it was never 50-50. Might be 52-48. Whichever gender had the most people, then that one would naturally accept their ad more times, right? And so what the system was learning was that was the most favorable ad. It wasn't looking at the gender at all. It wasn't learning on that. It was just learning on what's the most popular ad. So I got really excited because I found a bug. I found a bug in machine learning, y'all. So I had to open this bug up. This was unlike any bug I've ever written before. I'm used to writing a couple of steps to recreate the thing. You put the expected result, you put the actual result, and if I'm feeling really generous, then maybe I'll throw in some screenshots and some log files. But with this one, this was like writing a paper. There was no expected result that I could write in a one-liner. I had to write, how did I train this thing, right? What models did I expect to be generated? How do I know those models are there, right? Why do I expect this certain result? And what's the actual result that's going on? So I spent a couple of hours writing this bug report. It was good. I felt really proud. I opened it at the highest severity. And then Resident Expert, he got the bug report, he read it, and he closed my bug. You won't believe what he said. He said, well, it works on my machine. I couldn't believe it. I was crushed. I thought that I found this amazing bug. I thought maybe I have a clue of what I'm doing, and just like that, he crushed me. So I nursed my wounds for a few minutes, and I said, okay, let me go over and talk to him. So I went and talked to Resident Expert. I said, great, it works on your machine. Show me where I went wrong. So Resident Expert says, well, and then he gives me all of this theory of machine learning and all of this jargon, and basically says he has a more complex scenario than I have working on his machine, so he knows that machine learning is working. I said, okay, I've had enough of this day. I'm going to go home, and I'll look at this again tomorrow. I could barely sleep for thinking about this bug, and what could I have possibly done wrong? So I came back the next day, and I was fresh, had a clear mind, fresh set of eyes, and I began to go through my setup again. So I'm looking at the code again, line by line. I keep running it, I keep adjusting the numbers. Nothing's changing this output. So I called my team lead over. I said, can you do me a favor? Look through this. You know, I don't really know this machine learning stuff. You know, I just did the best that I could, but obviously I messed up somewhere. He said, Angie, stop it. You've done the research. You've studied the product. You've written this beautiful script. There's nothing wrong with it. I'm looking at it. Logically, it's sound. It's a bug. So I reopened the bug. Now, Resident Expert, he writes In the bug comments, some theory, some jargon, and basically says how he has this complex scenario, more complex than mine, working on his machine. And I simply reply, well, it doesn't work. And I left the bug alone. So this bug stayed open for weeks without anyone touching it. And then finally, we had to ship. Well, we can't ship with the highest severity bug open. So now the product owner calls a meeting. And the meeting went something like this. The resident expert had to come in and plead his case on why is our machine learning working, and I had to plead my case on why it wasn't. So resident expert, what does he do? Gives a bunch of theory on machine learning. And when this guy talks, you listen, you believe him, because he's really smart and he uses really big words, you know? So everyone was like, okay, yeah, sounds great, sounds like it works. I couldn't compete with that, right? I didn't want to debate him on that level because I would lose. So I decided to take another approach. I didn't talk about the steps that I went through. I didn't talk about how I generated models. I didn't talk about data structures. I said, listen, here's what's going on. Let's say we have one of our customers, e-commerce, and they have people coming to their site. They are buying the pants like hotcakes, the men are, right? And then we are getting that information about the men buying the pants like hotcakes, and we think that it's a great idea to say, instead of showing more men the pants ad, let's show them the dress. Even though the men are buying the dress less than 1% of the time. And we show them this dress ad over and over again. I said, our customer is going to be unhappy, and we are going to lose them. Do what you will. Now, when I gave this story, now people understood the severity of what I was talking about. The ears perked up. The product owner looks at resident expert and says, run her scenario on your machine right now. So he says, okay, tap, tap, tap. He runs it. Guess what? It doesn't work. He turns red in the face and he says, I don't know why I doubted Angie in the first place. That felt pretty good. So what did I learn from this experience? That as technology advances, so must our test approaches. So some of the notions that we had back in the day about things have to be exact, and you have to know what's going to be the outcome before you are able to test it, that's dead, right? This technology is becoming more and more advanced, so our techniques must as well. The need for automation became a lot more apparent. So as developers, sometimes we'll create something and then, do a little sniff test, maybe a little bit of unit testing, but most likely none of the above. So automation, this was the key here. I was running 2,000 API calls. That's not a sniff test kind of thing, right? That's not something anyone wants to do by hand. When I needed to crank this up to 10,000, can you imagine trying to do this by hand, right? So it became really apparent that we needed to automate the testing of this. But there was still a need for thoughtful and critical testing. A lot of times we think having coders on our team is enough. However, resident expert, he knew how to code and he knew machine learning. And yet he was going to ship this thing without the most basic of scenarios working. So our developers need to level up in thoughtful and critical testing skills. And then plain old common sense can still trump an algorithm, right? So when I needed to fight on behalf of our customers, talking about the tech itself wasn't going to get the job done. I had to paint the picture where people understood the impact that this would actually have on our customers. So don't be afraid to fall back to what you know is right. A lot of times we'll see where testers or other developers will just kind of fold when you have the subject matter expert or the lead developer on the team telling them, no, this works. You're stupid. He didn't say that, but you know. But you see where they kind of fold and crumble, and you might be inclined to say, oh, okay, I'll close the bug. But hey, got to use our POX method here. Now, if this thing would have shipped and learning was broken, the worst that would have happened is we would lose some money and lose some customers, right? Seems like a big deal, but when you think about this in the grand scheme of life, it's not that huge of a deal. Yet we're using AI for lots of other types of things as well, other types of applications. So we have to look at it in the context of security, of privacy, of ethics, of bias, all of these different things, right? I'm terrified to think of an AI-driven world where we're not testing these things and we're just looking at them as magical boxes. All right? So, my friends, the future is here. I beg of you to test it. Thank you.